The pressure of a fluid can be measured by uh, different principles. First one is balancing by liquid column. Second one balancing by spring or dead weight. We will discuss manometer. It's a device working on the principle of balancing by liquid column. These devices are used for measuring the pressure at a point in a fluid by balancing the column of fluid by the same or different column of fluid. Next one is mechanical gauges. These devices are working on second principle, which is balancing by spring or dead weight to measure the pressure of. Commonly used mechanical pressure gauges are diaphragm pressure gauge, bellows pressure gauge, dead weight pressure gauge, and Bourdon tube pressure gauge. So Bourdon tube pressure gauge has been included in your topic that we will discuss later. Now we will move on to manometers. The first one is manometers. They are classified as simple manometer and differential manometer. The simple manometers can be further classified as piezometer, U-tube manometer, and single column manometer. First one is piezometer tube. The simplest form of pressure measuring device used for measuring moderate gauge pressure. By using this, pressure of a liquid contained in a vessel can be directly measured. From the diagram, you can see that it has got a tube, and one end of it is connected to the pipe and other end is open to atmosphere. We can measure the pressure directly, but the drawback of this piezometer tube is that it cannot be used for measuring high pressures and very low pressure, that is negative or vacuum pressure. Next one is U-tube manometer. This manometer consists of U-shaped tube. That is why it is called a U-tube. It has got a U-tube that has got two limbs. One end is connected to a point at which pressure is to be measured, and the other end is open to atmosphere. Generally, the manometric liquid we select is mercury, and advantage of using this fluid is that mass density of this fluid can be obtained easily and they do not stick to the tube. You can easily calculate the mass density of mercury and it does not stick to the manometric tube. Okay, that is the advantage of selecting mercury as the manometric fluid. Now you can see the diagram. It can be used for measuring both gauge pressure and vacuum pressure. The first one is it is used for measuring gauge pressure. You can see that liquid on the right limb is above the level of manometric liquid in the left limb, which is that darkened portion. The liquid in the pipe, you can see that it is shown in the pipe and the darkened portion is the manometric liquid. The right limb is, the level of manometric liquid in the right limb is higher than the level of manometric liquid in the left limb. It is showing that it is gauge pressure. That means that pressure is above the atmospheric pressure. The pressure in the pipe, the pressure of the liquid in the pipe is more than the atmospheric pressure. The second picture you can see on the right side, there the difference is that manometric liquid on the right limb is lower than the manometric level of liquid in the left limb of the manometer. The manometric level difference, manometric liquid level difference, we have to note. In the first case, the level of manometric liquid in the right limb is higher than that in the left limb, and in the second is for the vacuum pressure, the level of manometric liquid in the right limb is lower than the level of manometric liquid in the left limb. Here we can say that the pressure of liquid in the pipe is less than the atmospheric pressure. Next one is differential manometer. It's a device used to find the difference of pressure between 2 points in a pipe or two different pipes at the same level or at different levels. You can see that the pressure difference between 2 points in the same pipe or two different pipes at the same level or different pipes at the different levels. So it also has a U-tube filled with mercury as the manometric liquid. It is called differential manometer because we can find the difference, pressure difference. Here two diagrams are there. First one shows that the differential manometer is connected to two pipes at different levels, and the second one the manometer is connected to two pipes at the same level. The two pipes may contain the same liquid or different liquids. Next one is inverted U-tube differential manometer. Same as the shape is same as the U-tube manometer, but that will be inverted shape. That will be inverted. Inverted U-tube is used for measuring the pressure. Here the difference is that they can measure low pressures very accurately. Difference of low pressures very accurately. That is inverted U-tube manometer. You can see the diagram. The inverted tube is there. It is connected to pipes at two different levels, and it is mainly used for measuring pressure difference, lower pressure difference or lower level pressure difference. Here we use lighter liquids, not heavier liquid like mercury, but lighter liquids are used in inverted U-tube manometer. And I want to tell you that derivation is there for finding the pressure difference in differential manometer and inverted U-tube differential manometer. That derivation we will discuss in the next class. So I don't want to load you much in this class. Next class we will discuss it. As I said, accuracy is the main characteristic of inverted U-tube manometer. It can measure low pressure, difference of low pressure between 2 points in the same pipe or two different pipes. Next one is the mechanical gauges. They are working on the principle of the liquid column is balanced by spring or dead weight. As I said, here Bourdon tube. It's a curved or twisted metallic tube with elliptical cross, not the circular one. It's an elliptical cross section which is fixed and open at one end to receive the pressure which is to be measured. It is fixed and open, and the fixed end is open to receive the pressure which is to be measured, and the other end of the Bourdon tube is free and closed. You can see the diagram of the Bourdon tube pressure gauge. Okay, here on the elliptical shaped tube you can see that cross section is shown here. You can see that the linkage is there. It is connected to a pointer. Pointer is working with an pinion and sector arrangement. If the pressure inside the tube is greater than outside pressure, the tube tends to straighten out. The tube tends to straighten out. Thus operates a pinion and sector arrangement and thus turning the pointer. You can see it once again. If the pressure goes inside the tube is greater than the outside pressure, the tube tends to straighten out. As a result, that sector and pinion arrangement rule that will cause the pointer to move on the scale. The pointer on the circular scale indicates the pressure of the fluid. That scale will be graduated or it will be marked. From that reading we can calculate the pressure directly. And the advantage of Bourdon tube pressure gauge is that they have high sensitivity and good repeatability. That is all for today's session. I hope you all will go through this topic. You can go through it as many times as one as I posted as a video recording. Okay, learn it properly. So tomorrow or day after tomorrow I'll conduct a live session. Then we'll discuss it more. Come prepared and have your questions. We can clear your doubts then. Thank you.